Okay, today we're going to talk about graphing an equation in polar. So we already talked about graphing polar coordinates, like how do we graph a specific point. But now we're going to talk about how to graph an entire equation. And if you remember, just way back in Algebra 1 when you learned how to graph a line, you basically took a group of points, graphed those points, and then connected them. We're going to do the same thing for polar graphs. So every polar graph has two variables, the r variable and your theta variable. Your theta is going to be your independent variable, and your r value is going to be your dependent variable. So you're going to put those in and figure out what they are, and then you're going to graph each of those points. And then once you graph all those points, you connect them, and that gives you your graph. So pretty easy as long as you understood how to graph coordinate points, polar points, sorry. So if you take a look, I kind of started one here. Like I said, if you have an equation, we're going to, ours is 4 sine theta. We're going to come up with some theta values, plug those into the equation, get out an r value, and then we're going to turn those into points and graph each of those points. So if I plug in 30 to 4 sine theta, then I get the value of 2. If I plug in 60, then I get to radical 3, which is approximately like 3.7-ish, between 3.5 and 3.7. So if you graph 2 comma 30 or 2 comma pi over 6, that's this dot down here, and 2 radical 3 comma 60, that's right about here. And then if I were to keep going, then I would end up with this black dotted graph that I have right there. So that gives you all the points that you're looking for. Okay. Then we will also graph on our calculator, and if you want to graph on your calculator, you have to do two things. Number one, change your mode to polar, and then it's recommended that you use radian mode. It's not necessarily required, but it's good and helpful. And then you're going to press zoom 7 when you've typed in your equation under y1 to make sure that you have the right graph. If when you have pressed zoom 7 it still looks a little jagged or there's holes in your graph, then you can go ahead and change your theta step in your window value, but start with zoom 7. Okay. Here's a couple of general polar graphs and what they look like. So you'll see in a little bit, we'll do one where theta equals a number. That gives us a straight line. If you have r equals a number, then you're going to get a circle centered at the origin. If you have r equals a number times the sine of theta or times the cosine of theta, then you're going to get one of these off-centered circles that we have at the bottom. So that gives you a number times sine or times cosine theta. If you add a constant variable to your to your theta value, so 2 theta, 3 theta, 4 theta, etc., within your parentheses, then you're going to get a rows graph. And then this little tidbit here tells you how many petals you're going to have. So if your k value is odd, then you're going to get an odd number of petals equal to that k value. If your k value is even, you'll get twice as many. So I think I had 7 here, and you'll see that means there's 7 petals. 1, 2, 3, 4, 5, 6, 7, because that's an odd number. If I had 8, then there would actually be 16 petals. All right. The next group gives you a version of a heart-shaped graph. And based on your number values, here I have A and B. Those are just going to be constant numbers. So based on those A and B values, you'll be able to get what heart shape you like. So if your A value is greater than your B value, so that first number is greater than your second number, then you're going to get this kind of easily buffered out, I guess, heart shape. It's just not as indented. If they're equal, so you have 3 plus 3 sine theta, those would be equal. A and B would be equal. You'll get a very nice, pretty heart shape. And if your A is less than B, so you had 2 plus 3 sine theta, then you're going to get this little loop on the inside of your heart shape. If you do not have a sine or a cosine, that just gives you a straight up spiral with your A and B values. And then if you want the infinity symbol, then you're going to go through and you're going to type in r squared equals a squared sine 2 theta. Remember, you can't really graph r squared, so you'll need to take the square root of both of those to get that theta symbol, or that infinity symbol, sorry. All right, so how are we going to graph? remember we're going to make that table of values. So if I start with r equals 5, then I'm going to pick some theta values, and those are just random theta values from 0 to 2 pi. And anytime I have this theta value in this equation, r is always 5. So I'm going to fill 5s all the way through. That means every angle distance around the circle, the dot will always be at 5. So that's a nice pretty circle centered at 0, 0 with a distance of 5. If you go down to do 4 cosine theta, I remember, again, I picked some theta values here from 0 to pi, and then I went through and I plugged those in. So this would be 4 cosine pi over 6. That gives you 3.5. 4 cosine pi over 3. 4 cosine pi over 2, etc., etc. So you'll need your calculator for that part. And then I graphed each of those. So pi over 6 comma 3.5, I would go over 3.5 spaces and up pi over 6, and there's my dot. So I went through and graphed all of those dots and then tried to connect them the best I could with as close to a circle as possible. If you're graphing this one, the theta is 120, so every value for theta is 120. And then for your r values, you'll get just random r values anywhere from negative r to positive r. So you could fill those in as is. And you'll see that they're all along this 120 line. Remember, if I'm going positive r values, then 120 is over here. So those are going to give you those upper values. If I have negative r, then I'm going to have the bottom values down here on the lower part of that value. All right, last one is for secant theta. Remember, secant is the same thing as 1 over cosine, so really this is 4 over the cosine of theta. Plug all of our theta values in from 0 to pi right in here in the denominator. Again, I'm using my calculator, so 4 divided by the cosine of 0, that's going to be 4 divided by 1, so I'm going to get 4. 4 divided by pi, cosine of pi over 4, 4 divided by 5 pi over 12, etc., etc. Remember, the cosine is undefined at pi over 2. That's why I get the cosine is 0 at pi over 2. So then I have 4 divided by 0, that's undefined. And you'll see that the points start to go up, up, up. They're undefined way over here. And then once I get back around to the negative sides, then they'll come back over here at the bottom and go up, up, up towards the 0 value. Again, you can use your calculator to do that if you need so, but do know or do be ready to graph some of those by hand if necessary. If you have any questions, feel free to email me, and virtual office hours is on Thursday. Thanks. Bye.